Well, let's take a couple of corrections. When we use the sextant, okay, we need to take a couple of corrections. Let's explain the corrections first, and then we'll do the math, okay? So remember that one of the things that we did yesterday with the sextant was to put the sun, what's called the lower limb, right on the horizon, okay? Remember that's what we did, right? We did like this, we move the sextant until the sun touches the horizon, right? Okay? Which was pretty much this position. That's what we did yesterday, right, with the sextant, yeah? Is that okay? Yeah? Well, all these celestial calculations, okay, all the nautical almanac and everything, the distance or the angles are not referred to the lower limb or to the upper limb, are referred to the center of the sun, okay? So there is what they call the semi-diameter that we need to account and we need to consider as part of the calculation, okay? So you can, with the sextant, keep lowering the sun and put it right in the middle of the horizon. You can do that as well. But it's kind of difficult, right? Because it's kind of difficult to judge when the sun is going to be right in the middle, okay? It's very difficult, okay? So that's why most people use the lower limb, okay? So if you use your lower limb, you're actually measuring like a lower angle, all right? Because, I mean, if you put it down, so you are not considering this part. So when we do consider the altitude, we need to consider this little part, okay? And this part, the semi-diameter number, is in the nautical almanac. I will see in a couple minutes, okay? So if you use the upper limb, you pass it, so you have to deduct this, okay, or subtract this. For most people use the lower limb, so for us, what you have to do is to add this part, which is around 16.5 or 15 minutes. It's a quarter degree, right? Yeah, that's a quarter degree. But this one will also depend, the time of the year. Because remember that yesterday we said that the orbit of the Earth around the sun is not a circle, right? It's an ellipse, right? So, and the sun is not right in the middle, right? It's like a little move. It's what we call one of the focus. So there are some time of the year that the sun is closer to us and some time of the year is farther. Believe it or not, there are some differences here in the semi-diameter that you need to consider depending what time of the year you are. Okay, and then we'll see that in the nautical almanac. Okay, so when the sun is when the Earth, when the Earth is closer to the sun, the sun will be bigger. Okay, and then we're smaller. So no big difference, but something that we need to consider, and that's part of the nautical almanac. We'll take a look at in a minute. Do you agree with that? Are we fine with that?
So the book would account for it for you by just having it by the months.
No, the book will give you the altitude, and then we need to do some corrections. Okay. So this is one correction that we need to consider, and we are going to do it when we do the math. Second correction is what we call the deep error. Okay, so remember that the idea is to measure always the angle of whatever celestial value you have versus an horizontal line. Okay, but we are using the horizon of the sea, right? And the horizon of the sea actually is lower because of the curvature of the air. You see that?
Oh, geez.
Okay, so if you...
Well, we have to correct for that too?
I got to correct for that. You think it was that easy? No.
Let me ask you, Mark, wouldn't that really be more atmospheric refraction because of that you get the atmosphere is actually refracting light downwards?
No, not that, a little bit, but the refraction is more on this side though, actually. You see, that's what my next point. There's some refraction over here as well, but let's talk about this first and then with the refraction.
Oh, geez.
Okay, we understand, we are clear that, the Earth is curved, right? So we agree on that, right? Okay, well, so when you see the horizon there, actually the ocean is going like this, okay? So we are not looking like a horizontal like this, actually we're looking like this. So the altitude that we are measuring here, instead of being here, is actually more. So we need to deduct, what is called deep error, we need to deduct this part, okay? If you use the sextant, right? If you use the famous stick like this, no correction at all, okay? But if you use this little, there's a couple minutes, and that will depend of how high you are, okay? The higher you are, the farther you can see, right? So the lower the horizon is going to be, so the higher the error, okay? So we need to compensate for that, and the nautical almanac, there is a table for that. Don't worry, don't desperate. We'll see it. It's an easy fix, okay?
So we're also maybe 3 feet off the surface of the ocean.
Right.
Does that dip also include that correction?
Right.
Plus where I'm standing to
Right.
5 feet or whatever.
Right, let's say I'm a little bit like 6 feet. Let's say my eyes are like 5 feet, let's say something, plus 3 feet where above, it's going to be 8 feet, more or less. Doesn't have to be right exactly, okay? It has to be 7 feet, 8 feet, 9 feet, more or less, okay? So it doesn't have to, you don't have to go measure exactly how, okay? Around 8 feet, 9 feet is fine. But if you are on a boat, okay, depending how high the boat is, you might be 20 feet, 30 feet, okay? So that kind of height has to be compensated, okay? Again, you can estimate, I mean, you have to measure exactly, okay? But I mean, if you are here on the boat here, but you're on a big vessel that have like a 5, 6, 7 light decks, that is a significant altitude that you need to consider, okay? All right? Again, it's a little error. I mean, I'll show you how to do it, but it's something that we need to compensate as well. That's called deep error, okay? And then is what he was saying is the refraction error here. Because of the refraction on the atmosphere, okay? So this is what happened. The actual position of the body will be on a star or a sun or whatever is here, but because of the refraction, it will seem that it's higher, okay? So there is a little compensation that we need to do as well as here. Not difficult, don't worry, it's not difficult. But these are the things that we need to correct when we use the sectant, okay? And that's what people do, okay? So it seems to be difficult, but when you get practice, I mean, you do it, like this, okay? Don't worry, I just want to make sure that you understand the concepts, okay? Again, if you are using your backyard like this, the angle you get is the final angle, okay? No dip, no refraction, or nothing, okay? The angle that you get by doing the shadow, the length of it by this is just the right angle, okay? No need to correct for all this, it's just for the sextants, okay? Right? Is that correct? Yeah, are we fine?
So these corrections, I guess you're going in order from biggest correction to less of an effect, because the sun's a half a degree, apparent half a degree, and so that would mean that the center is a quarter of a degree
Right,
off the horizon.
right,
So you have to pretty well correct for that.
right. Yeah, and I will do it now.
So
Won't I?
others are smaller.
Yeah, the biggest one for by far is this one, which is like a half of the degree or 15 minutes more or less. Okay, half of the degree. No, sorry, no, 1/4 degree. Okay, 1 degree is 60 minutes. 15 minutes will be 1/4. Right. So this one is like 15 minutes or 1/4 degree. This is just, you will see, this is just like 2 or 3 minutes. Okay, this is a small one, and this one is a small one as well. Okay, that's the big one to consider. Okay, all right. Are we okay? Are you getting scared or no? No?
A little bit.
If you're gonna, stand up and leave, you can, okay? Don't worry, okay? And then go and get and buy a GPS, you can, okay? Don't worry, okay? So, all right, don't worry. No, it's not difficult, all right? Let me see something else. Well, this is the nautical almanac, part of the correction. I gave you a copy of this the other day. Most likely, I mean, I didn't bring it, but I mean, anyway, this is what I gave you the other day, okay? So let me show you how to do it. It's look difficult, but it's easy, okay? So 2 things that we need to see. This is one of the corrections of the sun, the semi-diameter over here. So the one that we need to do this first is to see what part of the year we are. Are we within October and March, or are we within April and September? So which of the 2 columns are we now right now? The first column, right? Okay. The only thing you need to know is pretty much how was the height you measured yesterday, okay? This only, I stop it here, right? But it goes all the way down, right? So let's say, just to give an example, that yesterday that we measure 50 degrees, but I mean, since I don't have the 50 here, let's measure that with 50 here. Then we see the real example, okay? Let's measure that we stop here. Then the semi-diameter we need to add 13.9 minutes. Very easy, okay? Just this column. If we're using the upper limb, we need to deduct, as we say. So in our case, we look at the height we measure, we look at the value, and that's all we need, okay? That's all the value that we need, and then we use it for the calculation.
Is it minutes of angle?
It's minutes, 13.9 minutes, okay? Less than 1/4 of a degree. 1 degree has 60 minutes, right? Are we agree? This is the number that we need to add. Then we are gonna go to the 50 degrees what we really took yesterday, right? But let me just to give you an example, okay?
So if we measure an angle of 21.34,
Right,
we would add 13.9
minutes.
minutes. That 0.34 is also minutes.
Yeah, this is 13.4, 13 point,
Up
yeah.
at the top it says degrees and minutes.
Right.
So it's minutes.
Yes, I want to say,
Where does it say that?
Right here.
what I see.
So right here, degrees.
Ah, okay, yeah, all right.
Oh, I like that.
Oh, that we have a real astronomer here, yeah?
Better now.
Next
Oh.
column is minutes.
Yeah, so,
Next column.
no, yeah, this is degrees and minutes of altitude, okay? So this is degrees and minutes of altitude with the sextant, okay? And this is the correction in minutes, okay? So yesterday we do, let's say that we did yesterday 21 point, let me see, 21.5, okay, 25 degrees will be right in the middle of here, and then the correction will be this one, Okay, this is minute. This is degrees and minutes, and this is minute.
So you
Okay.
subtract that 13 from that 20.
Actually, we need to add it to the. We need to add it. We need to add it.
It's got that little plus there.
Right. We need to add it what we said yesterday, right? Okay, because of the semi diameter. Okay. And I mean, don't forget about this. This is just, I mean, we are not going to use this because April, September. This is for the star and planets, so forget it. This is for Venus, forget it. Refraction, no, we don't need to use it because it's already included here for the sun. And this is the deep correction, okay? This is the other table that we need to use, okay? We have it in meters or we have it in feet, okay? Let's say that, I mean, I'm like 6 feet or a little less, plus 3 feet, so it's going to be around, let's say, around like 9 feet, okay? So what we need to deduct is 2.9 minutes. That's the deep error, okay? That's the curvature of the air behind the horizon, okay? So this is what we need to deduct, okay? Why? Because, I mean, it's an extra height that we are measuring, okay?
The refraction corrections on the same page.
Yeah, it's everything, okay? The refraction, don't worry for that because that's incorporated on this one for the sun. The refraction, this on this is just for the solar planet. So we're only using the sun is this column and this column over here. That's all we need to know. And then we'll check the real numbers, okay? What that will do. Is that okay? Yeah?
So you don't need the refraction number for
No.
the sun.
No, for the sun, you only use this one. When you use the star and planets, or Mars and Venus, or on the moon, whatever, you use this part. Okay. For now, forget it. We need to use only this one, and the deep applies to everything. Okay, to every whatever you want to measure. Okay, that's applied to everything. Okay. So you have it in meters, or you have it in feet. Okay, whatever you use it. Okay. So I'm more used to meters, so I use meter, but you can use feet. Okay. So same story. All right. Are okay? All right. Well, let's keep going. That's all the thing that we need to know, okay? No, it's no more than that, okay? So, not to worry. Let me see if something else I can show you. Okay. So, we're going to do the longitude calculation. So, let's see the concept first, and then we'll do the math. So, before doing this, remember that we're trying to do with the longitude. Let me step here, all right? Where are we? Here. So, we have... over here, we have a nice place called London, right? And that's the Greenwich meridian or the zero meridian, right? Okay, all the way down, right? Okay. So we know by looking at the nautical almanac at what time the sun crosses or crossed yesterday before us this part. Okay, we are going from the nautical almanac, right? And we know at what time, because we measure, the sun crosses this meridian, right? Okay. And since the sun travels 15 degrees every hour, okay, by measuring the time from here to here that they took from the sun to go from here to here, we multiply that by 15 and we get how many degrees it moves. All right? So we understand that? If I mean, in 1 hour we'll be here, right? The sun will be, but it's going to be right here. Right? But in 1 hour we'll be here. 2 hours, 3 hours, 4 hours, 5 hours we'll be here, and we're going to measure a little more than 5 hours. Okay? And then we get the exact time that we measured yesterday, multiply by 15, and that will give us the longitude. Okay? So that's pretty easy. Okay? That's what we want to do first. And then we'll do the latitude. Okay? Let's concentrate on this part first. Okay? And then we talk about latitude. Okay? I don't want to confuse now with both things. Are we clear with that? What we're doing with that? Yeah? Okay, well, let's do the math now. Okay? And see what happens. Okay? So for the math, I prepared like a simple Excel worksheet, but you can do it by hand, you can do a calculator or whatever you want. Okay, we do it by Excel because it's easy to show you. That's the only reason why. Okay, and we'll do. Let me get it because I didn't open the file. Give me a second to open the file because I forgot to open the file yesterday. Okay. Let's open the spreadsheet. So it's an Excel, simple Excel, and we are going to fill it, little by little. Okay. So we do it together. Okay. This is what it is. Okay. Don't get scared. Okay. Do it complicated. Okay. And it is complicated. No. Just kidding. Let me open the nautical almanac, by the way, because we are going to need it. You didn't bring the pages, right? No, nobody
I
brought
have
it.
it.
You have it there?
I have one.
But I will show you because I mean everyone can see it. Don't worry. No worry. We already have a plan B here. These are all the files I have Celestial Navigation, as you can see. So the nautical almanac is here. Nautical almanac. Let's get the 2024. And this is something that you can get online, okay? So I'll give you the details later. This is the Nautica Almanac. The place is called the nauticanalmanac.com, so very easy. You can load it from here. The only thing you need to do is to look for the correct page, okay? So we're gonna go down until, we did yesterday. Yesterday was February the 7th, right? Are we okay? Today is the 8th, so yesterday, most likely it was the 7th.
So what is this you're whipping through? Other months?
No, this is for every, you can see, for every, this is 4 areas. Yeah, that's for January. For every, you have every page cover 3 days, okay? For example, from January to every page cover 3 days. You have the sun, the moon, and the two islands we were talking before. And then you have the second page, which covers the stars and the planets, okay? You see Earth, Venus, Mars, Jupiter, okay? So we're gonna concentrate only on the page that talks about the sun, okay? Because that's what we're doing today. Then you go down, okay? So let me go a little faster. Until the page, January, let's go a little down. Until cover February the 5th, so we have to go one more page. February the 6th.
Every day has 3 pages.
Yeah, so this is the page that we're looking for, all right? So let's see we're looking at the right thing. So this is the page that covered February 6th, 7th, and the 8th, all right? So yesterday was the 7th, so we use the part that covered the 7th, okay? This is the part for the 6th, this is the part for the 7th, okay? If you go down a little bit, that's the part for the 8th, okay? So we're going to concentrate on this part, which is the part for the 7th, the 7th of February, okay? That's what I'm talking about, all right? Are we okay with that? Yeah, no, more or less? Okay, right, okay. So the first thing that we need to get for the page, as we said, is the first thing that we need to get is at what time the sun crossed the meridian, the Greenwich meridian yesterday, okay? That's the first thing we need to do, okay? So how we check that? You see over here? Oh, let me put it higher so you can see from the back. You see? This is the meridian pass, okay? At what time it crossed Greenwich, the Greenwich meridian, right? Today was the 7th, it was on 12:14, always UTC time, right? Okay, so the sun didn't cross, Greenwich at 12 o'clock exactly, right? Why? Remember that the day before we talked about the ecliptic, that the sun moved faster and slower during the year. So this year, the sun is moving slower, okay? That's why it passed 14 minutes later, okay? It didn't pass exactly at 12, it passed at 12:14. So that's the first reference that we need to take, okay? Is that clear? And then you see there's not much different during the days, right? But if you move down the calendar to other days, you will see that this goes down to 0 or goes to minus, okay? 11:50, 11:55, okay? So the first reference that we need to know is at what time the sun crossed Greenwich, all right? And we have is 10:14. Yeah?
14 minutes and 4 seconds.
Yes. Oh, this part, yeah?
Yep.
Yeah. So we tell 12:40, okay? Just to make it easier, okay? All right. So then let's go back to Excel. All right. Let's start completing this, okay? We're going to do it little by little. The time that we took yesterday that the sun crossed the meridian was 12:14:10 local time, right? That was the Florida local time, okay? That's what we took yesterday, right?
I thought it was 11.
No, it was 12. I think it was 12.
12:40, 11.
12:40, okay?
Whatever, right?
That's fine. That's fine, okay? No. Okay, so the first thing that we need to do is to convert this to UTC time. So how do you convert to UTC time?
Add 5.
We need to add 5, so that's easy. So that's 17. Minutes and seconds don't change, right? Okay. So minutes and seconds are going to be the same. All right? Are we okay? Yep. All right. At what time we said that it crossed Greenwich time? 12. It's not seconds, okay? 12:14. Okay? So this means, and this is just, let me move this. So if you subtract 12:14 from this one, they will give you the time difference was 5 hours, 26 minutes, 10 seconds, right? It's this time, right? 17:40, 10 minus 0, 10. 40 minus 14, 26, 17 minus 12, 5. Okay? Are we right? That's simple math, okay? Yeah. Right? That was not difficult, okay? All right, so we know that the time difference, so going back to this, Sorry for reiterating, but I want to show you understand it. Which means that it took for the sun 5 hours and 26 minutes to move from here to here. Okay? Is that fine? Are we agreeing on that? All right.
So we're correcting for ourselves back to Greenwich.
No, we are just estimating, we are calculating the time that for the sun to go from here to here. 5 hours, 26 minutes, and 10 seconds, I think. All right? Okay? Well, the only thing that we need to do now is to calculate how much is that time in degrees, okay? Which is the difficult part, but we'll do it slowly, right? So we know that it took 5 hours, 26 minutes, and 10 cents to move, and we know that the sun moves at 15 degrees an hour, right? So the only thing is to multiply 15 times this, okay? But, I mean, before doing that, we need the difficult part is we need to convert this from hour minute to decimal, because we cannot multiply 15 by this, okay? So the only difficult part, and we're gonna do it slowly, is just to how we convert this, okay, from hour, minutes, and seconds to decimal, okay, which we 5 hours point something, okay, and we'll do it. Are we okay with that? Yeah, are we agree with that? Okay. So let's do it slowly, okay? And now we're doing the computer and you will follow. So how many, the thing we need to do is to convert the seconds to minutes and then the minutes to hours, okay? And then we get just one number, okay? Sorry if I go too slow, but I want to make sure everyone understand, okay? I know that some of you may know how to, or may know how to do it, but I mean, let's do it slowly, okay? So first thing that we need to do is we divide this by 60, okay? Right? So which means that 10 seconds equals to 0.17 minutes, all right? So then we add, second step, we add the 26 minutes that we already have, and we add the 0.17, okay, which is 26.7, all right? You follow me so far, all right? And now we need to convert the 26.7 to hours. How we convert that? We divide it by 60. That's not difficult, huh? So now divided by this, so we divide this by 60, okay? So what will be the total time then? Will be the 5 hours that we already have. Oh, sorry. I'll do it with both hands. So the time difference is going to be the 5 hours plus 44. Oh, what happened? There's something done wrong. This plus this. Okay, there we go. You see that? The 5 hours, 26 minutes, and 10 cents converted to decimal is 5.44 hours. Okay? No, that's fine. And now we can multiply by 15. All right? Are we okay? You want me to repeat this, or do you understand how you do it? Yeah, you get that? All right. If you don't understand, let me know. We'll do it as many times as you need. Okay? That's the only difficult part. Okay? Once you get used to that, you do it like this. So trust me. Okay? Well, now what we need to do here, we need to multiply the 5.44 hours that it took for the sun to move from Greenwich to our local meridian by 15, right? And this 85.54. Okay, this is this plus this times this is this. Okay, you wanna that's the formula, right? So you want to do the formula, it's the same, right? But you wanna do the formula. Let me do the formula, but it's this times this. All right, which means that our longitude is 81.54 degrees. All right, okay, and the only thing that we need to do is now is to convert. You can leave it like that, or we can convert this back to degrees and minutes, okay? Just to show it like how the GPS will show it, okay? So that will be the inverse process, okay? Any idea how to do it? Which is easy, right? No? Right, so, right, exactly. So the 81, let me show you this. The 81.54, we can divide it in between 81 and 0.54. Okay, let me show you that. So you can say 81.54 or 81 plus 0.54, right? The same story, right? So we separate the integral part from the decimal. Okay, that's what we did. All right, and then the only thing that we need to do is to multiply this. If we want to convert this to minutes, what we need to do? Multiply it by how much? By 60. Okay, well, so the final result is going to be the 81 minutes. Okay, and we need to multiply this times 60. Okay, and that's our longitude, right? 81 degrees, 32.4. All right. Anyone with GPS here? And I know they're doing. Go ahead.
I looked it up and I was
81,
using
1847.
How much?
81, 1847.
1847. So we are like 17 miles away or so, okay? Which is fine, okay? But it's not fine, but it's okay because
No, what was that number you just gave out?
81, 1847.
what answer did he get? What was his answer?
81, 17.
18, 47. So 81 degrees, 18 minutes, 47 seconds.
So the difference is like another 16 minutes or so, which is 16 miles, a little less than 6 miles. So why we have that difference? Any idea why we had the difference in longitude? Any idea why? Because the time that we took the site was 17:40:10. The real time, remember that we saw here? Let me show you, let me see if we can put it here. The real time was 17:38:40. It was like a minute and a half before. Okay, so we were late. Let's say in taking the site. Why? And other things because this is it's very difficult to put this north south exactly. And also in my case, I was helping you guys to take the site, so I was looking like this. Okay, it's already there. The time. Okay, if you do there and understand there, you will get like a little better number. Okay, it's not gonna be exact, but you might get between 5 and 10 minutes there, 10 seconds difference, okay? Right, so don't worry for that, that's the difference, right? Because this was the correct time, or the real time, and we took a couple of minutes later, 1 minute later, okay? That's the error, okay? And again, when you do it at home with time, you can expect between 5 and 10 miles difference in longitude, okay? All right, let's go back to the Excel. Are we clear how we did this? Okay, are we clear with this? So quickly, we took, this is the time that we took, we said that the sun was crossing the meridian from local time converted to UTC. We check on the nautical almanac the time the sun crossed Greenwich, and then we took the difference, right? 5 hours, 26 minutes, and 10 seconds. Then we converted this to decimal, and we got to 5 hours, 44. We multiply that for the 15 minutes, 15 degrees an hour, and we got that the sun moved 81.54. All right, and we convert it to degrees, and that way we can go longitude. Okay, that's it. That's one part of the deal.
8154, but it was 44, right?
No, it was 81.54.
You multiplied it. Okay.
Right. Yeah. But this place, no, this time this is this. Then we divided the integral part and the decimal. And the integral part is the same. We converted the decimal part to minutes, and that's what we got. We multiply this by 60. Then I'll send you a copy of the spreadsheet, okay? Don't worry, you can play with us later, okay? All right? Is that clear? How we got the longitude, okay? Again, it's a little far from where it will be. Yes, because again, we were doing like many people going around, okay? We didn't stay there quickly. Between 5 and 10 miles difference, that should be the best you can do with this system, okay? All right? So what else? What are we missing? What's the second part that we need to do now?
Latitude.
The latitude. Okay. So you think it was enough? Now it's more. Okay. Well, the latitude is it's not different. It's not difficult. We need to explain a couple of concepts. For the latitude, we're going to use this. Okay. But before doing this, let me explain to you a couple of concepts that we need to understand. Okay. And as you can see here, we have the deep correction and the semi-diameter correction we talked before. Okay. But before we do that, let me explain to you the concept of zenith. Okay, here's an M, but it should be an N. It's zenith distance. Okay, let me explain to you what zenith distance means. Okay, let's talk about this for a second, and then we go back to this. Okay, so let's go back to the presentation, and if you understand something or anything, let me know. Okay, we'll repeat it as many times as we need. Okay, let's start. Let's see this concept, which is important. Okay. Let's see projects. Anyone know what the zenith distance is or mean? No? All right. All right.
It's the distance between the difference between the geographical position of the sun and your reading of the latitude.
Right. That is exactly right. But let me explain the details, and then we'll get to that point. Yeah, you're right. So, yesterday we're not on a boat, but we're on the shoreline. Okay. So remember that, I mean, this part is the deep arrow that we need to consider and all that stuff. But well, anyway, we measure this altitude, right? From here to here. This is the 50 degrees that we measured yesterday, right? Around 50. It was a little less, but let's say 50, okay? Just to make it easier. Or 49 something, I'll show you the number later. Okay, let's say it was 50 degrees, okay? The zenith distance is the complement from this altitude to 90 degrees, okay? So if this altitude that we measured yesterday was 50 degrees, how much would be the zenith distance? How much? 40. 50 plus 40, 90, okay? It's just the complement, okay? That's the only thing. Which means is the distance from your zenith. The zenith is the point right above you, right? So that is the distance from you to the sun, okay? This distance, okay? The altitude is this, okay? But the distance from where we are to there is this one, okay? This distance from zenith to the sun, okay? Which, as Randy said, is the distance. It is so we are here, right? The zenith will be here, right? Yeah, that's what will be the zenith, right? And the sun is here, right? So the zenith distance. Let me see if we can do it without breaking anything. I've been practicing it at home, don't worry. No. You think I'm improvising? No. So you have to listen to my kids. What are you doing? Are you crazy? No, I'm a scientist. Okay? All right, this is the zenith distance. Zenith distance is this distance, okay? This angle, okay? From the zenith to this, to the sun, right? Let's say that is here, okay? This is the 40 degrees. Okay, the 50 degrees we measure is this, okay? So let's say that this is part, okay? This is the angle that we measure right to the ocean, and this is the zenith distance, okay? So this is the distance from the zenith to the sun, or whatever body we're measuring, okay? You understand that? Are we clear? Yeah? Okay? Now I want to show you why we need that distance, okay? That's the only part that we need to understand. Any question about the zenith distance, what it is?
How can you actually work with the level? How can you actually discover the exact zenith?
No, we don't have to, okay? No, we don't need to. But we need to know that, I mean, if we are measuring...
Degrees.
No, we don't measure, because if we know that from the horizon, right, we are measuring 50 degrees, the rest is going to be 40, okay? So we don't have to measure it with any instrument, okay? So it's easy, okay? It's just a vertical line, okay?
It could be off 5 to 10 degrees one way or the other, and thinking that might be the zenith.
No, because if you measure the altitude from the ocean, the rest is going to be the zenith, okay? So it's the rest to get to 90 is going to be the zenith, okay? You can measure, there's some instrument that you can do. You can level, put something in the right level and everything, you can do it, but you don't need to, okay? All right? Are we clear with that? Yeah? No? Yeah? Okay. Well, let me show you one more concept, and then we do the latitude. Oh, sorry. This is going to be charted. Let me see if we can see it, because it's kind of light, but let me see if you can see it. And this is something that we need to pay a little attention, okay? A little. Let me show you the chart. Okay. Let's pay attention for a second to this chart, okay? I want to move to the other side. So here are like 3 different possible scenarios, right? So which is the Earth, this is the equator, okay? Northern hemisphere, southern hemisphere, right? Okay? So one scenario could have been that, I mean, that the boats or our position is in the northern hemisphere, which is right, that's where we are, and the sun is in the same hemisphere, right? Meaning that the declination of the sun is positive, right? This is one scenario. Is that the scenario that we have yesterday or not? No, because what is the sun declination? What's the sun, by the way? The sun, what was the sun? What?
Below the horizon.
No, it was below the equator, so it was like south declination, right? Okay. So this scenario, not valid. What about this one? We have our position, and the sun was in declination, right, above us. Okay, that was the scenario that we had yesterday. No, right? Because that would be that we were where is it? Here. We were here, and the sun was above us. Okay. What is the maximum declination of the sun? 23.5, more or less, right? What is our approximate latitude here? 24 something. Will the sun will be over us at some point in the world? No, never. Okay. So that scenario will never apply to, at least to South Florida, because the sun will be always south of us. Okay. But if we were somewhere between the tropics, that could be the case, right? So if we were somewhere on here, we were here and the sun would be outside. It could be. Okay. That could happen. It's not going to be the case on our. It's not going to be our case, but that could happen. Okay, particularly between the tropics. Go ahead.
Did I get what you just said? So the sun passes within 22 degrees, like to the Capricorn, to the
Right.
Cancer tropic.
Right, let me go there. The
Right?
tropic.
All
We have
the
tropic.
time. That's where it
We
will
have
always be.
right. The tropic of Capricorn is here. The tropic of Cancer is here, right below South Florida, right?
So we'll never have it straight overhead.
The sun will move between the two tropics always. They will never go up or higher or lower. Okay. Here we are 24 degrees latitude. We are always, like a higher latitude or northern of the sun. Okay. So that's why we can never have this scenario, right? Okay. Because the sun never have a declination higher than where we are. That could happen if we are on the Caribbean, if we are in Central America, in Panama, northern Colombia, whatever. As long as we are within the tropic, we can have the scenario. If not, we can't. Okay. So this scenario is not valid. So can you see this one from there? From there? So what happened yesterday? We were northern the equator on the northern hemispheres, and the sun was south. Okay. So this was the scenario. Okay, that we had yesterday, right? Do we agree on that? Yeah. Okay. Well, let's look at this. The latitude that we are trying to calculate is what? The angle between the equator and our position. Okay, this part, right?
Yeah.
This angle over here. That's the latitude we are trying to calculate, right? Do we agree on that? Latitude is always measured from the equator, right? So the latitude is this distance, okay? Which will be the distance from the equator to here, this distance. All right? Okay? All right. So that's what we don't know, okay? I'm going to try to calculate. What we know this part, okay? Which is the declination. We know how many degrees the sun is south of the equator, and we get it from the nautical almanac. Yes, it was around 15. Okay, then we check the exact number. We know that this number was about around 15. Okay, and this part, the distance between our position and the sun, is what we call the zenith distance. Remember that we said that our position to the sun is the zenith distance. Okay, at the zenith distance, how we calculate the zenith distance? From the altitude that we take to the sextant. So we said that with the sextant we took 50 degrees, the complement of the rest will be 40, meaning the zenith distance is going to be 40. So we know this part and we know this part, which are angles, right? So if we know this part and this part, we know the latitude is going to be what? Zenith distance minus the declination. And that's all the mystery. Okay?
What do you call that distance right there? What distance?
This is the zenith distance we talked about before. The zenith distance, the complement,
zenith.
the zenith.
Oh, I'm
Yeah,
sorry.
sorry, me. Okay, okay, the zenith, because in Spanish is zenith or whatever, no, it doesn't matter. So this is the zenith distance minus the latitude, minus the declination of the latitude. Okay, if we were here, it would be different, right? The latitude will be the declination minus the zenith distance. Okay, and if we are here, the latitude will be the addition of the zenith distance or the declination. Okay, so that's what it is. Okay, so the only thing you need to understand is what are the graphics, what is your position to respect to the sun. Okay, so are we clear now then that the latitude is going to be the zenith distance minus the declination? Yeah, are we agree on that? Is that clear? If you understand, let me know. Okay, but it's simple. Okay, that's all we need to know. Okay, if you understood this, now we can go and calculate the latitude. All right. Sure. You still have energy to continue, or? Right, but let's do the last part, okay? Let's do the math. So a couple things there, okay? So let's do the math. Right, so this is the second altitude I took yesterday, right? Around 49 minutes, a little less, yeah? 49 minutes, 53 cents. It's not going to be pretty exact again because I was walking around and when I realized, oh, give me the second, okay? So I take just one side. What you do in practice, you take at least 5 sides, 5, 6 sides, and then do the average, right? Because yes, I was, walking around and helping you with the sextant. I took just one side, which was 49.53. 49 degrees, 57.3 minutes, okay? This is the altitude, okay? That's what I took yesterday, okay? Let's use that, okay? But and again, in practice, you take more than that. So let's go by the correction that we talked before. The first correction that we need to take, which is going to be a negative correction because we need to deduct it, okay? Is the dip correction. How do we calculate the dip correction? Let's go back to the nautical almanac. Where is it? Here. Let's go back to the nautical almanac.
Okay.
No, this one. Sorry, I had to open a different page. Sorry, but I forgot to open that before. Go to the correction tables. Go to the sun meridian. What is it? Here. Let's go to this one. Let's see if we can. Okay. So deep correction. So how high we say we were, more or less? The altitude of the sextant, we say 9 feet, more or less, right? Because we see 6 feet, okay, plus 3 feet more from the ocean level, right? More or less, okay? If that's the case, the deep correction will be between 9 feet, around between these two numbers, so the correction will be minus 2.9. So we need to deduct from the height, from the altitude of the sextant, 2.9, okay? Do we agree on that? Are we okay? All right?
Where did you get the 6 feet and the 3 feet from?
Because I'm, let's say that I'm 6 feet,
Is that what you're using it with your eye was?
is the level of my eyes to respect to the ocean. I'm 6 feet and we were, let's say, 3 feet, higher than the ocean. That's why we get 9. Okay? All right? So that's our work. Don't worry about it. Okay, so it's minus 2.9, right? So here we put minus 2.9. Okay? So as you can see, from the altitude that we took from the sextant, we deducted 2.9. Okay, so we get 4954.4. Okay, are we okay with that? That's easy, right? Just this minus this. Okay, so easy. Now the other thing that we need to do is to take the semi-diameter correction, right? So how do,
Vary with somebody's height?
right? Of course, yeah. No, the human being, no, but because you're a little shorter, I'm a little taller, so it might be 9 feet. Okay, yeah. So you will be maybe 8 feet. Right, maybe 8 feet, okay? But again, if we are on the vessel, on the deck, maybe 20 feet, 30 feet, 50, whatever, okay? So, all right? So let's go again back to the Nautical Almanac. Here, the corrections, and let's get the semi-diameter correction. For that, the altitude that we took was 49, hold on, let me see the number again. So the number was 4954, okay? So that number, so what we do is 49 will be between 47 and this one, right?
Yes.
49 something is going to be between these two numbers, right? So the correction, we need to add 15.4, okay? Do we agree? Remember that this is for the part of the year that is October to March, okay? Okay, well, so now go back to Excel. And here we need to add now positive 15.4. Okay. All right. So look at this here, right? So the new altitude is 49 degrees, 69.8. Okay, this is more than 1 degree, right? Because 1 degree will be 60, right? So the only thing we need to do is convert this. So what we will do, we add 1 degree, and we deduct 60 from the other, so it's going to be 9.8. Okay? So do we agree that these numbers are the same? 49 degrees and 69 minutes is the same as 50 degrees. We took 60 from here, we put it here, we add it here, and then we put 98. Is that correct? Yeah, so far? All right. Well, the zenith distance is always the 90 degrees minus the altitude that we took. That's what we said, right? Remember, the zenith distance is the 90 degrees minus the altitude. So it's going to be 90 degrees minus this. Okay? So the only trick that we need to do here is 90 minus this. Okay? The problem is if we do this minus this, we have to do some calculations. So the only thing that I did here, the only trick here is instead of 90 degrees and 0 minutes, we can write 89 degrees, 60 minutes. So we move 1 degree to here. Okay? Do we agree on that? Okay. And now the only thing that we need to do, is to deduct this from this. 60 minus 9.2, 50.22, 89 minus 50, 39. Okay? And that's our zenith distance. Okay? Okay? Do we agree on that? It takes a little time, but I mean, it's not complicated. Okay? All right? Remember that sometimes you need to move around. Go ahead.
69.8 is in minutes, so that's 1 hour and 9.8 minutes.
No, this is minutes, right? This is degrees and minutes. This is more than 60 is more than 60 minutes is 1 degree, So we move 1 degree here, we added here, and then we deduct 60. That's what we got. All right? Okay, and what the only number, the only number that we're missing? The declination, right? Well, go back to the almanac. I'm sorry, yeah, no, that's one to this part. The time, what was the time that we took the, we do the size 17 something, right? 1740 or so, right? UTC, right? So the noon side,
Yeah.
the noon side was between these two, right? It was 1740 or so, right? Yeah, all right? So it's gonna be between these two, right? Between these two, all right? Are we okay? So how much was the declination? 15 degrees with, let's say, it was at 17, it was 19.5, at 18 was 18. So let's take like a midpoint in here, go like, say 19.1 or 2, more or less, okay? 15 degrees, 19.1, okay? That was the declination on the sun. You can interpolate it exactly if you want, but just, we don't need that much precision. So the declination is gonna be between these two, 15 degrees south, 19.5, 18.7, let's say 19.1. More or less. Okay, that was the declination at the time of the site. Okay, are we agree? Yeah? No? No? Okay. How much we say? 15, 19.1? So we said 15, 19.1, right? All right? Okay, and the last thing that we need to do is the latitude. We said we're going to deduct the declination from the zenith. Well, so the only thing we do, we deduct this minus this, and then we copy the formula if you want, just to make it easier. Okay, and that's the latitude. Okay, please check, Houston. Please confirm.
That's close to where we are.
Yeah, it's close. Yeah,
Yeah, we're off by 7 minutes.
7 minutes, which is 7 miles more or less. Okay, right? Again,
In the water.
yeah, yeah, around the water. Yeah, all right, but not that far. Okay,
Marathon.
all right.
You can still make it to short.
Well, someone, do me a favor. Someone that has some, or maybe you can write. Let's go to Google Maps and see how far it does. So can someone write down these two, this one and these two? I mean, the latitude and longitude. No, write it down, whatever, on a piece of paper. And are we okay with that? How we got there? So let's go to Google Maps now and see how far we are. Any question in the meantime? How we got there? How we did the math? It was clear enough. Yeah. It takes time.
Read it over a bunch of times.
It takes practice, but I mean, when you get practice.
Out of this class, I got the concept
Yeah.
of how this works.
No, the idea.
Important thing.
The idea is what you get the concepts, okay? Then you practice and do it, okay? Well,
Well,
let's.
without the charts, you're kind of lost. Even if you have the protractor and the time,
Yep.
you'd have to have a lot of knowledge and experience
Mm-hmm.
to swag at it, to get an idea.
Without that book.
Just to get a swag at it.
Well, so did someone write down the? Okay, hold on a second. Stay. Keep it there for a second. Let's locate our real position first, right? Let's locate our position and we measure. That's why we have Google Earth, So I think that we are marathon.
There's sombrero right there.
I think that we are here, if I'm not mistaken.
Nope, to the left.
This one, right?
Nope, right there.
Right there, right? Okay. So we do is let's do this. We're gonna take a line in miles. Actually, we measure nautical miles, but let's do in miles, okay? So we start here, okay? So someone can tell me the latitude, longitude, whatever you have first.
So longitude is 81, 32.4.
Okay, let's say 8132. That's all.
Latitude is 24, 31.1.
Yeah, keep it a second. 81, how much?
8132.4.
So it's gonna be
I
like
don't think you know what you're doing right
here. You see there? You see here? This is. Let me move this.
now. Oh, is that so? Okay.
Yeah, so hold on, let me move this so you can see. So here, I'm moving this, right? So when I move this, what it changes is this part, okay? Latitude and longitude. Okay? I want to position this part on the latitude and longitude we calculated, okay? And then we measure the distance, okay? That's what we're doing. So tell me again the longitude, 81, how much? Okay, let's say 31, okay, just there. And the latitude?
Latitude is 2431.1.
24, 34.
24, 31.1 minute.
I need a little more scale. Uh, 24, 31, you said? 24, 34.
24, 31.1.
Okay, around there. That's it, okay? So this is our real position, and this is where we calculated, okay? And the distance is like 16 miles, all right, away, okay? Why again? Because we didn't take the right time, and also detected some errors, and we did quickly, right? With this method, I mean, the best you can do is probably between 5 and 10 miles, okay? So that's the best you can do with this particular method, okay? So you might think that 16 miles is a disaster, yes or not, okay? Depending on how you measure, okay?
You just cross the ocean.
Right, that's what I mean. So it might look a lot there, okay? But if you start to, right, but start zooming out, okay? Look at this. See? So is there a difference now? So 16 miles really makes a difference from here to here. If you are crossing from, from Mexico to here, it doesn't make sense. If you are crossing the ocean from here to here, this little arrow makes sense. We don't care, okay? So it's more than that where you should be, but if you even you get between 5 and 10, that's more than enough that you see where you are anywhere in the world, okay? Again, it's not going to take you home, all right? That's clear. But to cross the ocean is enough, okay? That's what we need, all right? And that's how you calculate it, okay? That's all the math. It's not that complicated. It takes some time. But before we go, before you resign about this and go back to the GPS, let me show you a couple more chairs. Okay. Any questions so far? No? Are we clear? Are we clear with that? All right. Any question on the procedure, how we did it? No? Are we okay? Then I will share the presentation, and you can call me or send me an email if you have any questions. Let me show you a couple more charts just to finish. Okay. So let me show you. Hold on. Let me put the presentations. What we did between the last 3 days was what we call the latitude calculation. That's what we said, right? So what we did was to use what is called the noon side, right? That's what we did. That's the technique, right? But there are other more advanced techniques, and one of the techniques is the triangulation method. When instead of taking the crossing the sign, the meridian, we take two celestial bodies and we triangulate, okay? Same thing that the GPS will do, right? Same principle, okay? But we need to take the sun here, and then triangulate. We need to take one star and one planet, 2 stars, whatever 2 or 3 bodies we can find, depending on what is available, right? And what we do is like a triangulation method, which is a little more complicated, but it's nothing out of the world. And then you can get a much better precision, okay? So just to give you an idea, and not just to scare you, if you do a triangulation method, it will be something like this, okay? So no, don't panic, okay? Sorry. Don't panic about it. This is, for example, between Venus, and this was made in the middle. I did this on the crossing the Atlantic, right, on the cruise ship. It was Venus and Arcturus, and a star, right? So you do all the calculations like this, and then you graphic this, and you get your position, okay? And this position is probably 1.5 miles away from the real position GPS. So you can get that kind of precisions, okay? It's a little more complicated, but if you see it, it's pretty much the same steps, right? The sectant altitude, we compensate it for dip, as you can hear. We get the final altitude. We calculate the position of Venus. Somewhere here we have the declination, and we get the zenith, and the distance from the position was 1.2 miles, okay? That was the difference, okay? The real difference versus GPS, okay? Just to give you an idea how it works, okay? But if you think that it's too difficult, okay, don't worry. There's always a solution in life, okay? In particular in modern life, and you can use some software, okay? There's always a software there, okay? Right. But there are many softwares around that you can use. This one is a free software designed by a couple of UK geniuses, okay? It's called Astron. It's for free. Then I give you the address and everything. It's called Astron. And this is something this is site that I took this morning, okay, 6:45 in the morning, right before sunrise. In the case of Venus, looks a little complicated, but what you do is you put the day, the month of the day, which is today. You put the time. It was 11:48 because it's UTC time, right? You need -5 will give you 6 48 in the morning. That's what I took it this morning, right? With the other sextant, right? With the Japanese sextants. Then the only thing you need to put is what body are you measuring, which is Venus in my case. Then you put your assumed latitude and longitude. I put exact coordinates, okay, in the GPS coordinates, okay. Can be assumed or compute the exact coordinates. And the only thing you need to add then is the sextant altitude here, what I measured. What I measured this morning was 17 minutes, 17 degrees, 33 minutes. And the program will do all the calculations. And finally, we tell you that the azimuth, the angle of Venus at that time was 125 degrees, let's say. And look at the arrow, the distance, 0.2 miles difference, okay, from my real position, okay? So you can do this with a sextant. You can get to this kind of accuracies with sextant. Today was a quiet morning. It was very clear ocean, very well defined the horizon and everything. But it was perfect condition. But with perfect condition, a very good sextant, you can get 0.2 miles. Okay, it's not impossible. Okay, so this is possible. Okay, you are not always get there. With the triangulation, what you can expect is probably 1.5 2 miles. Okay, this was very good today. All right, so just to show you can do it. Okay, so don't disappoint if you get 17 miles. At some point you get a little better. All right, and just to finish, okay, let me recommend you some reading materials. Okay, so this is the page of the Nautical Almanac. Just to get the Nautical Almanac and the correction tables and everything is here. Just go to the Nautical Almanac here. And you will go down here and you will see it, okay? So you can download the Nautical Almanac, all the correction tables, everything that we did, is we got from here. You can get a book that is over there, or you can get it from here, okay? And the second thing that we recommend, if you want to get deeper and get more knowledge, there is a nice book, which is this one, okay? Is this book over here, okay? This book over here was English by an Englishman called Tom Cliff now, which is this one, which is an ocean navigator. He crossed the ocean I don't know how many times. So was written by him. And the good thing about this is, it was written by a sailor, right? So it's a thin book, it's simple and right to the point, right? It's not a scientific book like this, written by some astronomers, that people, have to be aware, huh? You have to be away from that people, okay? That are very technical. This is not seriously. This is like a very simple, written by someone that use in practice, okay? So you want to learn something a little more, you can buy this book online, okay? Then I'll share the presentation and you read it, okay? Yeah, clear. So it's clear. Kun Life or whatever it's pronounced. Kun Life or Kun Life or whatever it's pronounced. Okay. And that's it for today, guys. Any question? Anything else? Are you still alive there? Yeah. Okay. Okay. Well, we lost some people in the middle, but there were some survivors. Okay. That's good news. Okay.